we talk about some more advanced stuff. You will use constructor and destructors in your assignment or assignment 2. One or 2. So it will be after the break. You have to know these things we are talking today about. Destructor, move constructor, copy constructors are a must when you have pointer data members. Pointer data. If you don't have pointer data members, don't worry about them. You can put them in your code just to let you know when they are called. You can put whatever constructors and destructors we call today, just to know when a destructor is called, when a constructor. But be aware that these functions we are talking about today are needed when you have pointer data members. That's why we have an example with arrays class and tstring class, because they are tstring like a pointer to char. We need this stuff. Another issue is some of the tools we are talking about are part of C11, very recent stuff. Right. And here we have, again, templates, the first half, and references and move semantics in C11 is a good place to find information about that. Things, move semantic, which start talking today, but it will continue tomorrow, yes. Constructors, remember, are automatically called when objects are created. We don't normally call them explicitly, except when you declare pointer variables. New circle, and then there, implicitly you call the constructor. Initializer lists should be used whenever possible. Whenever you can use initializer list instead of assignments, do that, because it's the a better style, better efficiency. So, just to remind us, when initializer lists are the only way to initialize data members. What type of data members are initialized just by initializer list, not by assignments? Remember from Monday? Constant data members, perfect. And reference data members. These are the 2 cases. You can't use assignment for constant data members, right? Destructors are called implicitly for us when the variable goes out of scope or is destroyed. When we have data members which are pointers, the system, be aware, the system provided destructor might trigger memory. The thing is that when you have destruct variables which are pointers, sometimes you have, this is a pointer int, let's say, which means you have this allocation somewhere, and the system provided destructor for your class, which contains a data member of pointer int type, will return to the system this area, the pointer. Memory address is considered not necessary, and this will stay stuck there. So we have memory layer. You will see what is provided by the system for the classes having data members of pointer types, it's not working as you might imagine, because when you declare a pointer type variable for that, it's something, gets a memory address, and assuming that you have allocated 10 spaces, then this is the memory your data uses. When the destructor is called, the system is not aware of this part. It just returns this memory address to be allocated. It's our responsibility to make data type using pointer data members avoid memory. Java uses a different approach. It has garbage collection, which does this deallocation for us. But you will see that life is easier there, but you have to be aware of other issues. So let's have a look at a simple array class we might want to design. Be aware C++11 has an array class, and if you need to use an array, use that class. This is just for demonstration purposes. As you can see, we have very few features. Assumes that our array type gets two data member, a pointer to an int, where we will allocate. We will see, we will link this to a sequence of integers, and m size, which keeps track of how many elements are there. Now, the way to work with such constructors is this. When we construct an array of this size, we pass one argument of int type, and our constructor, first of all, sets the data member to this argument and allocates memory. So with this construction, what we get is m elements is this pointer, and then we have here size m size elements. What is there? You don't set the values in the constructor because you don't know exactly what value. Normally, the elements in the array are set by the default constructor of the array elements type. That's why it's a requirement. Each type you might think would be used in an array should provide a default constructor. And as soon as you declare an array of elements, those come with default constructors, and that default constructor is used. Therefore, we don't assign values in the constructor to individual elements. It's this the way to make your type efficient, not waste time with a for loop to set data in each element from 0 to m size -1. And this is how most vector works in C++, how choose and other stack and other data types work. Right, but my point is your constructor allocate memory. Therefore, when objects of array type goes out of scope, they should to return this memory to the system. Because what is provided by the default constructor is not good enough. So we have to construct, whenever an array object is created, memory is allocated for that array on the heap. We have seen dynamic at runtime. If we don't provide our destructor, this allocated memory stays in the system and we have a memory leak. And if we have big arrays, this can be a big problem in your program. Right, notice here, in a while loop you construct variables of size 50. It's not big, but it depends on how many times this while loop goes, because if you have 1,000 times while loop going times 50 memory cells allocated, it becomes big. Destructors should be constructed for our array objects in order to fix the problem of memory. Be aware, whenever an object is going out of scope, the destructor is called implicitly for us. When you use delete on a pointer, the constructor is used by delete. So this is the benefit of using delete instead of free, like we have seen for new. Notice, pointers data member. As soon as you have a constructor using new, it means that you have to implement all tools I will mention after we finish talking about them. So, for a class, you have only one destructor. You can't overload the destructor. The syntax is this, tilde, and the name of the class, simple. In general, you don't have arguments, in general, because all you do is just use delete. Sometimes you might have size equals 0, if we have the size elements, just for information. Sometimes you do more than that. For this array, remember m size was the number of elements in the array. If we return the memory to the system, we should set m size to 0 as well. But for the moment, we talk about how to deal with syntax of the destructor. Tilde, the array, the type of the class, and mostly you implement it not in line. Okay. Class name in front. No return value. No overloading. Because we used this notation in the class constructor, remember, you have to use this syntax, delete square brackets, because we have worked with array elements, and call it 1m elements, right? So it was not only one element allocated, it was allocated m size element, right? This is the only thing you have to be aware. If we consider this example, we have a global variable, J, which allocates 10 memory for 10 elements. Another one, a local scope inside main, it's a local variable, okay, and a pointer variable. What we are required to do is just call delete on this element inside main. All other destructors are called implicitly for us. So the destructor for A is called here. Before, when the function main ends, this is called, the destructor for A is called, and after we finish running the function, the global variable destructor is called. Right, so you have to be aware of the syntax difference. We have talked about delete one element because we have allocated one element here for delete an array of elements, and the syntax and what you do in a destructor. So destructors are called in the reverse order of the constructors. But normally you will see you have the same number of destructor calls as the constructor calls, but the constructor can be any type of constructor. Default constructor, custom constructor, copy constructor, move constructor. We will talk about that. So, as you can see, constructor called before any function. Destructor when main terminates. At local scope, the constructor is called when we define that variable and when the object ends its scope. static local scope. The constructor is called when, remember, the variable enters the first time in the scope, and the destructor called when main terminates, like for global. Static variables. Dynamic variables, they are invoking their constructor when new is called, and they are alive until delete is called. Until delete is called, okay? So, to make things a little bit clearer, I put together some code. This is an incomplete code, and now I have added to your string the full code. There is a t-string declared, and in order for that code to work, this is what we have. Comments from the previous thing. Let's see if we can force it here to compile and run. So, as you can see, I have put here a constructor, a destructor, and just to demonstrate when these are called. Right. So after we have constructed our class, it doesn't use pointers, as I mentioned before, but you can have destructors and other tools there just to understand when these are called. Be aware something like this is in the final exam, so you should know when a destructor is called, when a constructor is called. Final exam will have something related to inheritance, but the constructor and destructor call comes from here. As you can see in this example, we have the type defined there. Everything is in line because it's just for demonstration purposes. We have a global string here, and this part is on your string, on your slide. We have a global variable. We have a function which is defined here, and inside the function we have a local variable simple on the stack. And here is on the heap, which is return to the system, delete key, and then we construct another string variable. And then we have main. In this we have a static variable, we invoke the function, and then this is the end. So what happens? First of all, you know, everything starts from main, but global variables are processed as soon as possible. Therefore, constructor call for a global string. I passed for the constructor m string here as argument, right? So this is m string gets the value of that argument. Notice constant reference to string is a way to work with that. Use initializer lists, right? And with that m string gets the value as static string. a global string. I was here, sorry. We are here. And then the constructor is called at this moment, constructor called a global string. Then, after we get here, we have the static variable constructor. Constructor called a static string. And then we enter the function. Sentence 1 is this great code or constructor called is this great code or what? So we are inside this function, remember? Then we have p declare, and the constructor, a pointer to a string, is called. We call delete p. Therefore, we have destructor called here. We construct another t-string, another sentence, and we are at the end of the function. Notice what destructors are called. I said in the reverse order of constructors. This is the destructor for this is called. We can pass arguments for strings in the destructor. So for this, we have this destructor. This was sorted, and then we have the destructor for sentence 1. So this is called here, right? We are at the end of main. Our static variable is destroyed, and because we finished, the global variable is destroyed. Yes?
Do we even need to call delete? Because I just ran a program which just does it by itself once it gets to main.
Once again?
So if you get to int main, to the end of int main, it just seems to call destructor by itself. Like you don't seem to need to actually call delete.
Which one's destructing by itself?
So the destructor is basically called at the end of int main. But so it seems to me you don't even need to declare that, correct?
We don't declare what?
We don't need to call like delete p, the line delete p.
You have to call delete on what you have allocated. Everything else calls the destructor implicitly. You don't have to call the destructor yourself anywhere. The destructor, like the constructor, is called implicitly. We haven't called the constructor explicitly here. So be aware, constructors and destructors are called for us by the system. We do what we do with other variables. For example, if you work with pointer to int and you allocate with new, you have to use delete on those pointers. This is exactly working like for the native types. Pointer to float, delete that pointer. So they are designed to work similar to the native types. You don't call delete on a simple integer variable. You don't. If you declare an int of a equals 5, you don't say delete a. It's the same thing for here. If you have a t-string defined, then you don't have to call destructor. My point is, it's a very simple rule. Whenever you have new in your program, you have to have a corresponding delete. That's the story. Outside this, everything is done by the system. Constructors, destructors are called by the system. But make sure that whenever you have a new, you have a corresponding delete. Otherwise, you have memory leak and problems. Right, so you have this on your stream. Change it, play with it if you want to understand what's going on. But there are simple rules, I would say. You have to get a little bit used to that. But this is valid in C as well, from current slides. So this is the constructor and destructor we were talking, and we have seen when they are called in that program. I demonstrate. Copying objects. So, with constructors and destructors in place, our classes can work properly without memory leak. So be aware the structures provided by the system are good enough if you have primitive data types or string types or vector types. Whatever is provided by the system comes well equipped with everything needed. So your classes using types from basic types, int, float, bool, or string, complex, but provided by the library, you don't have to worry about anything or memory allocated with it. But as soon as you declare your classes with pointers, then you have to make sure that you have constructors, you have destructors, otherwise you get garbage in your types. One of the issue is how objects are copied. When you have a type, like we have seen with a constructor, with a destructor, minimum type, minimum body, and you have functions getting objects passed by value, as you can see our array is passed by value, you can get into trouble very well, very simple. So your function, doesn't matter what the body is, when it's called on this object A, there is what is called a shallow copy. Remember I said here, when we have the class which has some pointer type like this, when the function is invoked, the constructor on that passed by value, specific constructor is called copy constructor. A copy of that A object is created, a copy. And that copy, you will see that copy create everything here. When the destructor is called, this pointer is returned, but that pointer works with a memory which was stored in A. And therefore, we have this one. Being the double freed, the pointer being freed was not allocated. So, at the end of the function, the pointer, which is exactly the same, pointer value, it's exactly the same in A1 and A, the pointer is returned to the system. Therefore, when main terminates, the pointer of A was already deallocated, and they say, oh, this pointer doesn't exist. I can't free anything because it was already out of the system. So be aware when you have types with pointer data member, the system provides a shallow copy. When an object is passed by value, each value of the original object is copied directly into the new object. When you copy a pointer, you copy the pointer. So in other words, this is a pointer and this is a value of pint, address, A0139. This is copied in A1, A0129. And when the function ends, this is released, is destroyed. Therefore, this handle is lost. That's why we have this problem. As you can see, m elements has the address here. The address. This address is copied in the function. So here we have a copy of this element, which are addresses. In other words, they both point here. When the function ends, this is the link or the address here is released to the system, and we are in bad shape. Therefore, we have to solve this problem. The destructor is called delete the memory. Unfortunately, we have A not going well. How to solve this problem, and this will be the last slide. We will continue on Thursday. One is, instead of using pass by value, use pass by reference. In that case, you don't make any copy. You don't make any copy, the constructor is not called, the destructor is not called. So when you work with pass by reference, you don't create new objects. Another way is use C-type pointers, another type of reference. But how these tools we work with solve this situation, they create what is called a deep copy. And this is the way to deal with our types. So instead of that pointing to the same memory location, what we want is something like this. This is the A element points here. When the function is called, this A1 should copy not only this, which is done by the system automatically, but it should ask for new memory location and copy across. This element there, this element here, this. When the function ends, this is returned, everything is fine here. This is called deep copying and is performed, you will see, in what is called copy constructor and assignment operator. But this will be what we talk to later. So we stop here, and on Thursday, tomorrow, we'll continue with this and whatever we need. Right, so